bokse Ukimuana Anainama Anainuka Ananahaya.
Hello, welcome to this video lesson where we'll be looking at a maths problem called the Tower of Hanoi. This is a pause and go video, so be sure to stop and attempt the problems along the way. To follow along with this video, you're going to need a sheet of paper. You can use one between two students, a pair of scissors, or a ruler to tear paper in a straight line, a flat surface, and somewhere to write down working. I have this whiteboard, but you're welcome to use a pen and paper or anything else that you have access to. The first thing we're going to need to do is construct our tower. To do this, you'll need your sheet of paper and scissors. You should hold the paper so that the longer sides are at the top and bottom and make 4 horizontal cuts across the paper to divide the piece of paper into 5 strips. Don't worry about making the strips the same height, it's not important to the puzzle. Once you have your 5 strips, we're going to need to cut each one into 2 pieces, but we should make each cut in a different place. For the top strip, make a vertical cut towards the left side of the strip, about here. Make the cut on the next strip down a bit further right, and cut the third strip approximately centrally. We're going to carry on moving our cuts towards the right for the 4th and 5th strips. You should now have 10 shorter strips which look like this. If we separate these out, you'll find that you have 2 pyramid shapes formed from 5 strips each. You'll need one of these, and you can give the other one to another student. If you'd like, you could make a 3-dimensional version of this tower. I made this one using a cardboard cereal box and scissors. Watch the end of this video for instructions on how to make this tower. Or feel free to design and create a version of your own. Now for the first problem. To start with, we're only going to be using the smaller 3 blocks from this pyramid, so put the larger 2 somewhere safe for later. Imagine that you have 3 available platforms on which you can place blocks, and that your tower begins on the left-hand side. Your objective is to move the tower from the left platform to the right platform, but there are restrictions on how you can move the blocks. Firstly, you can only move 1 block at a time, and the block that you're moving must be moved from and to the top of the tower on any platform. Secondly, you can't place a larger block on top of a smaller one, otherwise the smaller block would break. So now I would not be allowed to move this medium block to the same platform as the smallest one. I could put it on the other available platform. Have a go at completing this problem. See if you can do it in the fewest number of moves possible. You should now try to solve this problem. If you managed to successfully move the tower following all the rules, congratulations. Were you able to do it in 7 moves? This is the fewest number of moves in which this puzzle can be solved. If you managed it in more than 7 steps, you might like to pause the video now to try and refine your method. Here's how to solve this problem in 7 moves. Firstly, we need to find a way to move the largest block to the right platform, but we can't currently move this largest block because it's at the bottom of the tower, so we need to get access to it. If we move the smallest block first, and then the middle block to the 2 available platforms, we now have access to the 3rd block, however nowhere to move it to. To free up the rightmost platform, we can move the smallest block on top of the medium-sized one, now moving the largest block over to the rightmost platform. We can finally complete the puzzle by moving the smallest, then middle, then smallest block to build our tower on the rightmost platform. Having completed the problem with 3 blocks, using just 7 moves, for the next problem, we're going to introduce a 4th block to our tower. Now, starting with a tower of 4 on the left platform, and following all of the same rules, can you move the tower from the left to right platform? What's the smallest number of moves that you can do this in? Pause the video now to have a go. If you find that you could use a hint, watch the next section of the video. Here is a hint. You might find it helpful to use the fact that we already know how to move a tower of 3 blocks in 7 moves. Here's the solution. Firstly, we should move the first and second blocks to reach the third one. We can then move the third block so that we have access to the fourth. Since we want to move the fourth block to the right platform, we need to clear the right platform of any other blocks. So we should move the first and second blocks to the middle platform like this. Now we can move the fourth block over to the right platform, which puts us at 8 moves. If we then reverse the first 7 moves, we can stack the first 3 blocks onto the fourth to complete our tower. So we finish this puzzle in 15 moves. Some of you might have noticed some similarities between this solution and the solution for a 3-block tower. In particular, I mentioned the first 7 moves, which we reverse after moving the largest block. You'll remember that the 3-block tower puzzle could be solved in 7 moves. In fact, look at the first 7 moves again, ignoring the largest block. We move the first block, then the second, then we stack the first block on top of the second. Next we move the third block, and then reassemble the first 2 blocks on top of the third. This is the same process as when we moved the 3-block tower. To complete the puzzle, we move the fourth block, and that puts us at 8 moves, or 7 moves to move the smallest 3 blocks, plus 1 move to move the largest block. Finally, it takes 7 moves to put the 3 smallest blocks back on top of the largest block, which gives us a total of 15 moves. As a hint, I asked you to use the fact that you already knew how to move a 3-block tower. We could actually simplify our solution by moving all of the smallest 3 blocks at the same time, knowing that this actually takes 7 moves. This allows us to move the largest block, and we can then move the smallest 3 again in 7 moves, which gives us a total of 7 plus 1 plus 7, or 15 moves. Finally, you should try to attempt this puzzle using all 5 of your blocks. You might even be able to predict the smallest number of moves in which this puzzle can be solved before you do it. Remember, we already know how to move a 4-block tower, and we can use that to our advantage. Were you able to find the solution consisting of 31 moves? Were you able to predict that the shortest solution would have 31 moves without even completing it? Similar to how we treated a 3-block tower as one object when solving with 4 blocks, to solve the puzzle with 5 blocks, we can treat the top 4 blocks as one object and move them together, knowing that this takes 15 moves in reality. So the total number of moves needed for this solution is 15 plus 1 plus 15, which is 31. So far, we know that 3, 4, and 5 blocks can be solved in 7, 15, and 31 moves respectively. If we think about having just 1 or 2 blocks, which we can solve in 1 and 3 moves, then we have the sequence 1, 3, 7, 15, 31. Can you spot a pattern in these numbers? How many moves do you think it would take to move a 6, 7, or 8 block tower? You might have realized that each term can be generated from the previous by doubling and adding 1. This makes sense if we think about how we moved a tower by treating the smallest blocks together, moving them all, and then the largest block, and then all of the smallest ones again. In doing this, we're doubling the previous term to move the smallest blocks, and adding 1 to move the largest block. Continuing this pattern, we get 63, 127, and 255 as the next 3 terms. I'm sure you wouldn't have wanted to work these out by hand. You might also have noticed that every term in this sequence is one less than a power of 2. If you did, well done. This isn't easy to spot. We can combine this observation with the doubling and adding 1 process to prove that we will continue to generate numbers which are 1 less than a power of 2. Say we have some term which is 1 less than a power of 2. This could be any of the numbers which we've already worked out, or a different one. So let's use a general representation 2 to the power of n minus 1, where n is an integer. If we times this general term by 2 and add 1, we get 2 times 2 to the n minus 1 plus 1, which is equal to 2 times 2 to the n minus 2 plus 1 when we expand the bracket, and this is 2 to the n plus 1 minus 1, 1 less than the next largest power of 2. This explains why our sequence is going to keep generating numbers 1 less than a power of 2, and why we get 1, 3, 7, 15, and so on. This is an example of a proof by induction. Congratulations on getting to the end of this video. I hope that you enjoyed working on the Tower of Hanoi problem. Be sure to look at other Pause and Go videos for more lessons like this. Now, here is a short demonstration of how to make a 3-dimensional Hanoi tower using a cardboard cereal box. To follow along, you'll need some cardboard, a pencil, ruler, and some glue or sellotape. The first thing we need to do is draw a cuboid net onto the cardboard, which we will cut out to form our tower blocks. Start by drawing a square onto the cardboard. I'm going to be making this block 3 centimeters wide, so I need a 3 by 3 centimeter square. Next, we should draw the side faces of our block as rectangles. I'm going to be making my block 1 centimeter tall, so the rectangles are all 3 by 1 centimeters. Next, we add another square face, which will be opposite the first face we drew. Lastly, I'm going to add some tabs where we can apply glue to stick this block together. I actually ended up using sellotape, so these might not be necessary. Once we've done one block, we'll need to make 4 more of increasing size. I chose to make blocks 3, 4, 5, 6, and 7 centimeters in width. You should now cut around the outer edge of all of these cuboid nets. This could take some time. Once you've finished cutting out, you should have 5 cuboid nets of increasing size that look similar to this. Now you're ready to begin assembling the blocks. To do this, you should fold along all of the lines which you have drawn. Try to make your folds as clean as possible. I found that using a ruler made this a lot easier. You can now create the cuboid shape by joining the edges of the faces that you have created. To do this, either add glue to each of the tabs which you drew and stick the faces together this way. I found that the glue wasn't strong enough to hold my block together, so you can also use sellotape. I used 3 pieces of sellotape, one for each of the rectangular faces which wasn't already connected to both of the square faces. I then used a couple of pieces of sellotape to tidy up the edges. Now the only thing left to do is to repeat this for the other 4 blocks, and you'll have your very own 3-dimensional Hanoi tower. And remember that you should feel free to create your own towers from any materials which you have available to you.